Hi folks, we're going to take a look at number 17 from page 481 from the Unit 7 assignment. Okay, so here they give us the equations of two lines that are parallel and distinct, and they give us a point on the first line, and they want us to determine the coordinates of another point, this time on line 2, such that the vector formed by AB is perpendicular to L2. Now of course if it's perpendicular to L2, it's also perpendicular to L1, since those are parallel. So again, to do this problem here, I think it's best to draw a diagram and see how we can set something up. Okay, so we've got two parallel and distinct lines, so we'll call this L1 and L2, and we know point A on L1 is 5, 4, -3. Okay, and we need to find a point on L2 such that the vector from A to B is perpendicular to the lines. Okay, so point B is somewhere there, and it's got to be perpendicular to the lines. Now, as soon as you're hearing that you're looking for a vector that's perpendicular to these two lines, hopefully you're thinking that you're going to use the fact that a vector that helps to represent the line, okay, which in this case here is 2, 1, -1, okay, will also be perpendicular to this vector. And of course we know that perpendicular vectors have a dot product of 0. Okay, so hopefully that's stewing in your brain as to how you might, in terms of how you might solve this problem. Only issue is here is that point B, I don't know what point B is. I need to find point B, and I don't want to just use x, y, z, since that's going to leave me a lot of variables, but I know something about point B. It's on line 2. So that means that point B can be represented using this parametric equation. I know the x component of point B can be represented by 2 plus 2t. Okay, the y component of a point on line 2, 1 plus t, and the z component can be represented by 2 minus t, okay, for some t value. Okay, this should be helpful because now it takes the three unknowns, x, y, and z, and turns it into working with only one unknown, because that one value of t helps us determine both the x, y, and z coordinate. Okay, and so this is what I'm going to work with. So the first thing I'm going to do is I'm going to create my vector AB. Okay, so my vector AB here will be, okay, second minus first, so it'll be 2 plus 2t minus 5. Okay, then we've got 1 plus t minus 4, and then we've got 2 minus t minus -3, so plus 3. Okay, so that's the vector AB again with that one unknown. Okay, so let's clean this up here. So what do we got? 2t, 2 minus 5, -3, t, 1 minus 4, -3, and -t, 2 plus 3 is 5. Okay, so vector AB can be represented by this vector here, or this expression here, and I know that if I take the direction vector, okay, and I dot it with the vector created from A to B, I know that the dot product needs to be equal to 0 since I need AB to be perpendicular to the line. Okay, and then from here I think we should be able to solve it since we've only got one unknown here. So let's take this dot product. So we've got 2 times 2t minus 3, so that's 4t minus 6. Then we've got 1 times t minus 3, so plus t minus 3. Then we've got -1 times -t plus 5, so that's going to be plus t minus 5 equals 0. And here we've got a pretty easy equation to solve, so 4, 5, 6t, and here we have -6 minus 3, -9 minus 5, -14. Bring that to the other side, positive 14, so t is 14 over 6 or 7 over 3. Okay, now remember what we're looking for here is the point B, so be careful that you're not inputting this value into that set of coordinates which gives the vector AB. What I'm looking for is the point B. So B is just going to be equal to 2 plus 2t, so 2 plus 2 times, so that's 14 over 3. Then what do we have? 1 plus t, 7 over 3. And then we've got 2 minus 7 over 3, again taken from the expression for point B. And now we'll just clean this up. So this will be 6 over 3 plus 14 over 3, so that's 20 over 3. Here we've got 3 over 3 plus 7 over 3, so that's 10 over 3. And here we got 6 minus 7, so negative 1 over 3. And there's your point. Okay, so just to recap here, because this is a type of problem we haven't seen before, but it uses all the elements that we've seen in the past. Okay, so setting up the problem with the diagram, I'd say almost essential here. Okay, what really was the trick to solving this problem is that when we needed to work with an unknown point on this line, we represented that point using our parameter from the vector equation. Okay, and then from there everything followed pretty much as we would have done a similar